So far, we've learned how to calculate the probability of a single event. In this video, we will learn how to calculate the probability of multiple events. Whether the events are happening at the same time or successively will change the equations we use. Let's start by reviewing singular probability. In this example, I have a set of coins and I'm to draw a coin at random. The win conditions are set as such. If I draw a coin with a star, I win the game. What is the probability that I will win the game? %25. Now, let's change the win condition. To win, you must draw a coin with a star or a coin that has a purple symbol. Now, let's follow the same procedure as before. Let's take the number of star coins and add them to the number of purple coins. So the probability of winning is 6/8 or 75%. Right? Well, no. Can you spot the mistake? That's right. We double counted this coin. To find the actual probability of choosing a star coin or a purple coin, we must remove any double counted coins. So the actual probability of satisfying this win condition is 5/8, or 63%. When calculating probabilities with two or more conditions, we must remove any double counted items that fall into two or more categories. Let's take our coin problem for example. To find the actual probability, we had to add all the coins that fit the two categories, then take away any coin that fell into both categories. I can separate this fraction into three fractions. Notice how they all have the same denominator. This first fraction describes the probability of picking a star. The second fraction describes the probability of picking a purple coin. And the third fraction describes the probability of picking a purple star coin. Mathematicians also simplified the word "or" into this giant U, called a union. If we generalize this rule to any event for some arbitrary procedure, we arrive at what we call the addition rule. It states that the probability of event A or event B happening is equal to the probability of A plus the probability of B minus the probability of event A and B occurring at the same time. By the way, this upside down U stands for AND. In an office, the marital status of the employees are collected. If a person is chosen at random, find the probability that they are a man or not married. Anytime you see the word "or" in your question, your mind should race to the addition rule. The probability of choosing a man is 13/30. The probability of choosing someone not married is 16/30. The probability of choosing someone who is a man and at the same time not married is 3/30. So the probability of randomly choosing a man or a person not married is 26/30, or 87%. What is the probability of choosing a woman or a married person? The probability of choosing a woman is 17/30. The probability of choosing someone married is 14/30. And the probability of choosing someone who is a woman and at the same time married is 4/30. So the probability of randomly choosing a woman or a married person is 27/30. In other words, 90%. A more abstract way of thinking about probability is to represent the sample space with a rectangle. Then I draw a circle around all the elements that represent event A, and then another circle for event B. Notice how the elements that fit both criteria are in the middle. We call this area the intersection. To visualize the addition rule, we add the left circle to the right circle and take away their intersection. If the events have nothing in common, then there does not exist an intersection, and we call the events disjoint. If two events are disjoint, then the addition rule simplifies to this. The probability of choosing a coin with a star or a thunderbolt is 50%. Since I see the word or, I know I have to use the addition rule. Since there is no one in the office that is both a man and a woman at the same time, the two events are disjoint. Then the addition rule was simplified to as such, and the probability of picking a man or a woman from this office is 100%. Let's consider our sample space. And now let's use the addition rule, but now on all the possible events that can occur. After we remove all the double counts, we are left with this image. This tells us that the probability of having any event occurring is the sum of the probabilities of each event in the sample space. This sum is equal to 1. This is a very important result, and you must not just remember this, but you must understand it. The union of all the events is equal to 1.